Look at your thumb. Right. Now, imagine a machine sitting on the ridge of your fingerprint. It isn't a speck of dust. It isn't a bacteria. It is a fully functioning robot. It has a computer for a brain. It has sensors to feel the world. It can make decisions, and it is watching you. For 40 years, engineers have been stuck. We have built robots that can run, jump, and even do backflips. But we couldn't make them small. I mean, really small. But that era just ended. Researchers from the University of Pennsylvania and the University of Michigan have created the world's first fully programmable, autonomous micro-robots. They are smaller than a grain of salt. They are powered by light, and they cost just 1 penny to manufacture. Welcome to Genus Seasons. Today, we are documenting the birth of a new species. To understand why this invention is such a miracle, we have to talk about the micro-scale nightmare. You see, the laws of physics change depending on how big you are. For you and me, air is thin and water is fluid. If you want to swim, you kick your legs. Easy. But when you shrink down to 200 micrometers, which is the size of these new robots, water stops behaving like water. At that scale, the liquid becomes incredibly thick relative to your body size. To a micro-robot, swimming in water feels like a human trying to swim in wet concrete or tar. This is why the field was stuck for 4 decades. If you put tiny mechanical legs or propellers on a robot this small, the resistance of the water would snap them off instantly. You cannot just shrink a submarine. You have to reinvent the very concept of movement. And that is exactly what the team at the University of Pennsylvania did. They stopped fighting the liquid and started controlling it. The researchers at the University of Pennsylvania developed a propulsion system that has 0 moving parts. No gears, no motors, no legs. So how does it move? It uses a complex physical reaction called electrokinetic propulsion. Essentially, the robot generates a precise electrical field around its body. This field grabs onto the ions, charged particles, floating in the water around it. It then violently pushes those ions backward. Think of it like a jet engine, but instead of burning fuel to push air, it uses electricity to push the water itself. It forces the liquid to flow around it, propelling the robot forward. It glides silently through the tar. It is durable because there is nothing to break. It can operate for months on end. But a moving chip is just a piece of debris unless it has intelligence. And that brings us to the second half of this genius collaboration. A robot needs a brain. But how do you fit a computer onto a chip that is smaller than the period at the end of this sentence? This is where the University of Michigan comes in. Their engineering team holds the record for creating the world's smallest computer. The challenge wasn't just size, it was power. These robots are powered by light. They carry tiny solar panels on their backs. They have to run their entire existence on just 75 nanowatts of electricity. Let me put that in perspective. A smartwatch on your wrist consumes about 100,000 times more power than this robot does. The team at the University of Michigan had to completely redesign how computer circuits work to run on almost 0 energy. They succeeded. These robots are not remote-controlled toys. They are autonomous. You can flash light at them to upload a program, and then they are on their own. They sense temperature, they process data, and they decide where to go. Now, here is the part that feels like science fiction. Let's say you inject 1,000 of these into a patient to find a tumor. One robot finds it. How does it tell the doctor? It doesn't have a Wi-Fi antenna. It's too small for Bluetooth. The solution, the researchers found, is biological. They mimic nature. When the robot detects something important, like a change in temperature or a specific chemical, it communicates by performing a dance. It wiggles in a specific programmed pattern. An observer looking through a microscope, or even an AI camera monitoring the swarm, can read these wiggles like a language. It is exactly how honeybees communicate with the hive. We have effectively built a synthetic insect. It hunts, it thinks, and it dances to share information. But the most revolutionary part of this story isn't the science, it's the economics. Because these robots are made using standard semiconductor manufacturing, the same way we make chips for phones, they are incredibly cheap to produce. The researchers estimate they cost about 1 penny each. This changes everything. If a robot costs $1 million, you have one. If a robot costs a penny, you can have 1,000,000. We are entering the age of the swarm. In the future, we won't send one doctor to check your heart. We will inject a swarm of 10,000 robots. We won't send one probe to check a bridge for cracks. We will paint the bridge with a swarm of smart dust. The University of Pennsylvania and the University of Michigan have just opened the door to a new reality. The season of the giant machine is ending. The season of the invisible robot has begun. I'm Genus. Thank you for watching.